Let's talk about preventing shorts and checking our wiring prior to powering up. If we remember, all of our inputs on the top row here, 1 through 20, 21 through 40 are all our outputs. Our outputs primarily for this device, for this machine, are all of our solenoids. We're going to check and make sure that our outputs, solenoids, and our inputs, which is like this photoelectric sensor down here, our reed switches within our actuators, are not wired up to be a dead short. Remember, a dead short is going directly from positive 24 with a direct path to negative with no resistance in between. That can be done accidentally by, as we talked about before, wiring up a normally closed switch to go directly to common. When you close a switch, there's no resistance, and you allow 24 volts to go directly to the negative. So we're going to check it by putting in we're going to set our meters on ohms and check the resistance from the power supply, which is 24 volt on your terminal block. And the best way to do that is just place your positive lead into a secure spot on the terminal block and check it with the other lead, making sure that you've got almost direct continuity or no resistance. Once you've done that, just go along in what's called pin out. You're going to touch each one of these. Well, this guy is not wired up to anything, so it's off limits or outer limits of the multimeter. Go to the next terminal, step over, and remember these are all the outputs. And I've got some resistance here. It's not a short, but it is 32 kilo ohms, 30 kilo ohms. Well, if I do the math on that, 30 kilo ohms into 24 volts divided by 32,000 equals, about maybe 1 milliamp, not even, probably about 3/4 of a milliamp, which is not a concern. That's not a direct short. That's not going to burn up any device. It's very low wattage to have a single or less than a 1 milliamp. So if we go down the line here and check all the rest of these, we're going to find that they're all about the same. They're somewhere into absolute, complete open circuit, whether it would be OL, outer limits of the multimeter, or it's going to be somewhere in the kilo ohm range, which is going to be milliamps by the time you divide the 24 volts by that high resistance. You're going to have a very low current flow. What you don't want to see is anything in the 100 ohm or less that's close to being a dead short or is a dead short and will overload the circuit and burn something up. So after I pin out each one of these and check them, both the inputs or both the outputs and the inputs, and make sure I have at least several kilo ohm, then I can power up. And now we're going to talk about shoot a separate video for talking about how we power up and check the overall amperage through the circuit.